Hello, hello, hello. It is Wednesday, March 9th. I'm excited that all you guys have joined me. Thank you, thank you, thank you for being on time and being patient. That was a terrible emoji game challenge. I will do better next week. All right. So we are picking up where we left off. Last week, before break, we introduced the different algebraic vocabulary terms that are common for algebra. And now we're going to kind of dissect some of the words that we learn piece by piece. And this week is expressions. So watch this video and then we'll do our vocabulary game.
Welcome to your lesson on how to break down algebraic expressions. Now gather round, it's a mathematical phrase. You'll see it written down in a number of ways, with numbers, operations, and variables too, which stand for numbers as variables do. Variables are letters that represent numbers. Each variable has a coefficient, which is a number that is multiplied by. And if you don't see it, there's a 1 by its side. Now that we have the definition all set up, let's evaluate an expression. Now next up is 2 minus 4b. When b is 5, here's a couple of steps that we need for this ride. First things first, let's rewrite the problem. Before we compute, we need to substitute 5 for b so we can find the value. There's a couple of more steps. Let me show you how to. In order to finish the calculation, let's follow the order of operations. We multiply first. 4 times 5, I know that's 20. Then we rewrite. Now the next action will be subtraction. 2 minus 20, and that's it's like magic. When we evaluate 2 minus 4b, when b is 5, it equals negative 18. Do you hear me? It's like that. Yeah. Hey, if you're feeling algebraic, express yourself. Need some evaluating, just express yourself. An algebraic expression is a mathematical phrase with numbers, variables, operations for days. Express yourself. Hey, I said verbal phrases can represent algebraic expressions. Don't you forget, like 10 plus a number that's 10 plus n, or n plus 10, cause addition's commutative when adding or multiplying. If you get it now, I got another example, let me break it down. 2 less than 4 times a number. Time to identify the terms and simplify. You can try 2 and 4 are constant numbers, they won't change. That's a constant convert for the variable. A number we need a letter, let's use the letter T. Next, identify all the operations and put it together for evaluating. With less than, subtraction applies, and when we see times, it means to multiply. We need to multiply first, then subtract after. When we subtract, in order does matter. T is a number, 4 is what you want, as T's coefficient, 4 always in front. To make 4T, we not done yet. It's 2 less than that, then we said 2 less than 4 times a number is 4T minus 2. And if you got the same result, I believe that we do. If you're feeling algebraic, express yourself. Need some evaluating, just express yourself. An algebraic expression is a mathematical phrase with numbers, variables, operations for days. Express yourself. If you're feeling
All right, so the main difference between expressions and equations, an equation has an equal sign so you can solve it. An expression, sometimes we could combine like terms to simplify it, but we could never solve it because it does not have an equal sign. So today we're just working on translating words into expressions. That's all we're doing today. Next week, we'll start talking about equations, okay? All right, so let's play the vocabulary game because it's been a week away from, whoops. It's been a week, so we need to review some of these terms. So you could type your answers in the chat for me, or you can talk on your mic, okay? All right. To find the value of a numerical or algebraic expression, who remembers what that is? Is that a coefficient? Is that evaluating, or is that subtracting? Yes, Cameron, it is evaluating. Yes, yes, yes. When it's an equal sign, you're solving. Good job. The coefficient, remember the coefficient is the number before a variable. It is like it marries, they're a couple coefficient, they live together, okay? So blank are letters that represent numbers. Are those variables, operations, or coefficients? I'm so excited. You guys are so smart. I love this part of my day. The letters, that's when I started hating math, when they started putting letters in it. What do we call those letters? Variables, operations, or coefficients? Variables, yes, good job. All right. All right, to reduce a fraction or expression to its lowest terms. Is that a variable, operation, or simplify? Yes, simplifying. That's about all we can do with expressions. We cannot solve them because they do not have equal signs. So if they have like terms, we can combine them, or that makes it come down to its lowest terms, and that's called simplifying. Good job. Yes, yes, yes. All right. An algebraic blank is a mathematical phrase with numbers, variables, operations for days. Is that a coefficient, evaluate, or expression? Don't make me get my vocabulary on. An algebraic blank is a mathematical phrase with numbers, variables, operations for days. What was that word? What are we learning about today? It's a phrase, it can't be solved. You know it, don't be scared. Is it coefficient, evaluate, or expressions? All right, I'll give you this one. Don't get used to that. It is an yes, Adolfo, thank you. Yes, it's an expression. That's what we're working on today. Absolutely. All right, blank. A process in which a number is changed, such as adding, subtracting, dividing, or multiplying. Is that algebra, an operation, or expression? Yes, woo-hoo. It's an operation. PEMDAS is the order of operations. Good job. The blank of y is 17y. Oh, the blank of y in 17y is 17. Oh, 17y is a term, but what is the 17 of that term? Is that a variable or the coefficient? So the way it's worded is kind of weird, but they're asking you what is 17 in 17y. So 17 and y together is the term, but what is the 17? Is that the coefficient or is that the variable? The 17. Yes, the number that's married to the variable or the letter is the coefficient. Oh my goodness, I am so excited. You guys are so good at this already. Yes, the y is the variable. A type of mathematics in which letters represent numbers. Is that a term, a variable, or algebra? What is this kind of math called when they introduce letters? This is where Ms. Garcia exits stage left in school when they introduce letters. Yeah, that's where you guys are at right now, algebra. This is the algebra years of your life. All right, now what is they're looking at the, I'm sorry, the red parts of this equation. This is an equation because it has an equal sign. So the 3x and the 2, are those simplified? Are those terms? Or is that representing subtraction? 3x and 2. Yes, 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 yes. The 3 is the coefficient, the x is the variable. 3 and 2 are constants, but they are also called, they're both called terms. Yes. All right, the math teacher said, please blank each expression on the board. Show your work so that I can see how you found the value. What are you doing to expressions? Is it commutative, evaluating, or operating? What are you doing to an expression? You can't solve. Yeah, absolutely. That's right. Your first instinct is usually your right answer. Yes. So don't second guess on tests. What are you doing to an expression? Are you communicating it, or evaluating it, or operating on it? Evaluate, yes. Don't hate, evaluate, yes. In math, a single number, a variable, or numbers and variables multiply together. Is that an operation, a term, or evaluate? Not operation. Operation is addition, subtraction, multiplication, or division. So it could be a constant, it could be a variable, or it could be a term that has a, oops, or it could be a coefficient with a variable. So those are all terms. I gave it away, I'm sorry. So 3x, or 2 in that equation we just saw are all examples of terms. Let's listen to see how this beat is sounding. Okay. Too much of something. All right, I solved the blank problem determining the value of x. I solved the blank problem determining the value of x. Did I evaluate, term, or algebra? I solved the evaluate problem, I solved the term problem, or I solved the algebra problem. Algebra, yes. Y'all giving me backup of why your answer is right. Y'all go, y'all go. This is awesome. All right, I'm gonna try and vocabulary this. Let's see. I said verbal phrases can represent algebraic expressions, don't you forget, like 10 plus a number that's 10 plus n, or n plus 10 causes additions blank. Is that evaluate, commutative, or algebra? A hint is it has to rhyme. It's part of the vocabulary rap. Not algebra. 10 plus n, or it can travel n plus 10. And it means the same thing. What is that property called? Yes, commutative. It can commute back and forth, but it means the same thing. Good job. All right, all right. 4 plus 3 is an example of what? An expression, evaluate, coefficient. It just says 4 plus 3. Yes, it's an expression because it's just a phrase. It has no equal sign. We can't solve it. All right, what is this? 9 plus 7 or 7 plus 9. It's traveling, but it means the same thing. Is it algebra, subtract, or commutative? Nine plus 7, 7 plus 9. Well, I'm sorry, 9 plus 7 equals 7 plus 9. It's the same thing, even though the numbers traveled. Commutative, yes, yes. With the defense explanation of why your answer is correct, the teacher told the class to blank the fraction from 4/8 to 1/2. Is that an operation, term, or simplify? Simplify, to bring it down to its smallest terms. Yes. All right. 2 more, I think, or 3 more. What is the 17 in that term? 17y. Is it simplify, coefficient, or subtract? Yes, it is the coefficient. It is married to the y, meaning multiply. All right, in this problem, x is a blank. It is a placeholder for any number. What are those letters called in algebra? Variables? Yeah, you didn't even have to let me finish. This one I'm talking about. Good job. All right, last one. The subtraction sign, the addition sign, the division sign, the multiplication sign. Are those coefficients, algebra, or operations? Not algebra, operations. Those are the operation signs. It's not algebra unless you see some letters and variables. These are all expressions because none of these have equal signs. So the red is what they were asking about, and that is operations. All right, let's see what our beat sounded like. I got a little bit better. All right, so all of these, the read and response, the vocabulary cards, the quiz, I will download those and upload that into our post for today's live lesson video. So you have notes if you want them. All right. So now I want you to watch this algebraic video because it's going to show us how to translate algebraic terms into expressions. So you're going to take the words and write them into an algebraic phrase or expression, okay? And then you're gonna practice that on your quizzes, and then you're out of here.
Hello everyone and welcome to this lesson on algebraic translation. Now our aim for this lesson is how can we translate written expressions and equations into numerical form. So basically we see it in written form and we want to write it in terms of numbers and variables. Now before we can do that, we have to lay the groundwork here, and there's a few things that we need to know so that we can use them when we get to doing the actual translations. Now, if we had something like 7 plus 5, verbally we could express this, for example, as the sum of 7 and 5, and we would be done. But what if instead of a 7, we had a variable, we had the letter x there? Instead of saying the sum of 7 and 5, we would say the sum of a number and 5, because x is a variable and it could represent any number, so we're just going to call it a number. And even though x is the most commonly used letter, this applies to any letter in the alphabet that can be used to represent a variable, which is just some unknown value. So let's translate 10 plus a number. So again, it's an expression, so we have the number 10, plus we know is just addition, and then a number is just some unknown, we'll call it x. So that translates to 10 plus x. Now what if we add the statement 10 more than a number? Now we should know that more than is associated with addition, so our sign is not going to change. So let's think about this one differently. We have a number, some unknown number, some variable, and this phrase represents 10 more than whatever that number is. So in this case, we're going to start with the variable and then add 10 to it. Now, since this was addition, and because addition is commutative, the order didn't actually matter. But let's take a look at an example now using subtraction. So now let's look at 6 less than a number. So again, we see that word then. So we have 3 parts here. We have the number 6, we have less than, which we know is subtraction, and then a number, we'll call it n. Now this phrase represents a value that is 6 units smaller than whatever our number n is. So to find that number, we would have to take n and subtract 6 from it. So in cases like this, the second term comes first and the first term comes second. We have to switch the order. Now this is the case when we see the word then, and we're going to say that then is a switch word, which means that the operator stays in the middle, but the order of the first term and the last term is switched. So the way that it's written, the actual expression will be in reverse order.
Cool.
Moving on now, if we had the phrase the difference of 3 and a number, we could easily translate this. Difference is subtraction, and we have 3 minus some number, we'll call it p, so 3 minus p would represent this phrase. But what if instead of the difference of 3 and a number, we had the difference of 3 and twice a number plus 1? So now instead of p, we have to represent that whole expression, which we can call 2p plus 1. And we can enclose this individual expression in parentheses. So when performing algebraic translations, you can use parentheses to separate independent groupings. And now let's look at a number divided by 3 is 8. So we have a number, let's call it t, and we're dividing it by 3, so let's use it as a fraction, t over 3. And when we say is 8, that just means that it equals 8. So be aware that the word is or is equivalent to just means equals to.
And just remember that if you have equals, that turns it into an equation.
So a quick recap before we get into the examples. Remember that a number is just a variable. The word then, we call a switch word. Use parentheses for independent groupings, and is means equal to. So now we're ready for a few examples.
All right.
So first, let's translate the phrase the product of a number and 9.
All right, try that. Throw it in the chat for me. Let me see how you remember what a product is. We went over these terms a couple of weeks ago. What is a product? What are you doing to get a product? What operation would that represent? Multiplying, yes, yes. So translate these words into an expression. The product, which means multiply, of a number and 9. That's a good try. Where's my variable to represent a number? You can use n, you can use x, t, y, whatever, 9x multiplied by 9. Okay, so remember when you have a term that has a number next to a variable, that means multiplication. So do we need that multiplication again for that 9? If it's saying and 9, what operation am I doing when I'm adding? Yes. So try that one more time. The product of a number and 9. Product of a number and 9. Almost. Let him explain it because I'm gonna confuse you. This is hard for me to explain, but he does a really good job of it. But Tyreek, you're so close.
So we know that product just means to multiply. And what we're multiplying together is a number, we'll call it n, and the number 9. Now, n times 9 is fine, but we'll more commonly see it written as 9n without the multiplication sign, but that means 9 times n. Next, we have...
Did that make sense? Awesome. Okay, let's try this one. Half of a number decreased by 12. Listen to all those clue words. Half of a number. When you cut something in half, what are you doing? What does that look like? And then you're decreasing it by 12. If you're decreasing it, what operation is that? So this one is going to have 2 terms. Yes, half of a number is going to divide. And then decreased equals subtraction. Yes. So show me half of a number being decreased or subtracted by 12. What would that look like? That might be hard to do in the chat box. I think you can use the slash for dividing. Oh, how did you come up with a 24? We don't know if it's 24, we just know it's a number. So what do we do when it's just a number and we don't know what number it is? It could represent a number from 0 to 100 in millions. Yes, an X. So what would half of an X look like? What are we doing with an X? Half a number. The number is being represented by X, but we're going to cut that in half. So what does that look like as a term? I can't even see you, and I feel the wheels in your brains are going because you're trying to figure this out, especially on how to write it in a chat box. We're cutting that X, whatever X, it could be 24, could be 25, it could be 2025, but we're gonna cut that X in half. So what We're cutting it in half. Chop, 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 like the Fruit Ninja. What are we doing? What does that look like when you cut something in half in math? What does that term look like? What does the symbol look like? Yes. So X, half of a number. When you're cutting in half, what number is that? What number do you use to divide something in half? If I'm sharing half of my pizza with you, how many people are sharing that pizza? I'm going to give you half and I'm going to keep half. How many people are sharing? This is hard, I know. Keep going, you're there. If I have a pizza pie and I'm going to give you half of the pizza pies, it's only me and you sharing. I'm giving you half. I'm taking half, you're keeping half. How many people are sharing the pizza pie when we cut it in half? Here's my pizza pie. I'm cutting it in half. How many people can I share if I only cut it in half? Yes. So half of a number decreased by 12. Now what do I have to do? So it's X divided by 2, decreased by 12. What does that look like? Decreased. Decrease is going up or is decrease going down? What do we do to make a number decrease is going down? What operation would that be? Oh, Tyreek, you had it up there. When you put that 24, you were right with the second half. Yes. So you're subtracting it by how much? Ooh, that was a lot. I'm so proud of you guys though. This is a lot to process. That's why we're going really, really slow and we're dissecting it a little bit each week. So it's X over 2 minus what number? Decreased by 12. What do I write to finish this one off? When am I subtracting what number? Half a number decreased by 12. Decreased, would you have that? That's the minus, by 12. Decreased by 12. Oh, I figured that's what you were thinking about. Okay, I was right. Okay, so remember, an expression has no equal sign. So we're not doing anything to solve this, okay? We're just translating, like if someone speaks Spanish and I don't understand Spanish, I'm translating what they're saying into English so that we can understand it. So you're translating these words into an algebraic expression. So it told you decrease by 12 and you cut 12 in half, but you can't cut 12 in half because we can't solve it. We're not doing anything like that. We're just plugging in the words into numbers. So what is the number they gave us? It was 12. So it's decreased by 12, or subtraction sign, minus sign, and then the 12. That's it. So it's x over 2, which shows half of a number. We're cutting that in half, which is a fraction. Decreased by 12, subtract 12. All right, let's see how he explains it. Hopefully he does a way better job. Take a deep breath. This is hard. So that's why we're gonna do this for a couple of weeks.
Have the phrase half a number decrease by 12. Decrease by means to subtract. And now the first term is half a number. We'll call that number x. And half of it means dividing it by 2.
Which
so we
you
have
got.
x over 2 minus 12.
So you try to divide the 12 by 2, and you put 6. But remember, we're just translating from words to numbers or variables or terms, okay? We're not solving, there's no equal sign. We're not solving anything. So there's no math. You're just translating it from English to math, or English to numbers, or words to numbers. That's all you're doing for algebraic translation, okay? All right, I'm going to stop here because I want you guys to log into your quizzes, because I want you to practice doing these on your own. Once you're done, you're able to go. Take a deep breath, kiss those brains. You worked so hard today. I'm so proud of you guys. That was not easy. And we'll keep practicing until everybody's comfortable, and we'll move on to equations. All right. See, I do all this and it doesn't stay. It logs me out. All right, give me 1 second to throw it in there. Oh my goodness. I'm so proud of you guys. All right, in about an hour, I will have the video for this uploaded, and all of the documents that go with the Flocabulary, so that you have study guide notes in case you want to look back at anything in this video, okay? And this video that we were working on from YouTube is part of that YouTube list, master playlist that I made for you guys, so you can always watch that again. And I will throw the link to this video in the chat as well, in case you wanted to do some more examples with mashup math. Okay, you guys were awesome. I'm staying here until everybody's logged in and done, but I'm gonna stop recording and stop talking so you can concentrate. I'm so proud of you guys.